All right, cool. So now we're going to begin with integers and see how and where and how all those things integers work. So now this is quite interesting, especially with integers. So what are integers? And I think we're going to come across a lot of them because here we see it's getting to a section. Obviously, it's a data type. That's what we do know about an integer. I see we have integers, and then we're going to have floating point numbers. Type safety and type inference, we'll get to that and see what it means. Numeric literals, we'll also get to that. So what I will do, since there's a lot of things to cover here, I'll just break it down into topics as well. Booleans, we have tuples, and we also have optionals. And we have nil. At one point, I was really looking for nil, but now we have it here. But then, interesting. Interesting. We'll get into nils. Quite interesting. If statements enforced and wraps, unwrapping. We have optional binding. We'll get to that as well. And then we have implicitly unwrapped optionals. I don't know what that is, but we'll get into it. Error handling. Oh, by the way, these are all the basics. These are the basics. These are the basics. Quite interesting how all these are the basics. But yeah, I think once we get to the basics, we'll then step into basic operators and then strings and then yeah. But then so far so good. So far so good. So we're gonna continue with our strings for now. What is this integers? We just finished comments, semicolons. Now we're gonna move into integers. So what is an integer? Integers are whole numbers with no fractional components. Okay, integers are whole numbers with no fractional components. That makes sense. We're gonna have an integer called 0.555 or 0 comma. There's no comma or whatever. It's just a whole number. 1, 2, 3 until no comma, no dot, no whatever. Just a whole number, such as 42 and minus 23. Integers are either signed positive, 0 or negative, or unsigned, positive or 0. So okay, cool. So then that means I can create an integer like this. I can say var, okay, I'll just say number is equal to plus 23. So that means the number, the integer here is signed. Or I can do this. Okay, number negative 23. The integer here is, well, this one is signed positive, this one is signed negative, which makes sense. Or number 0, okay, fine, which is just the same, which says a 0. So that's what we learned here. Or unsigned, positive or 0. So then if I do something like this, then var number unsigned is equal to 23, then that means by default this integer is a positive, is positive, pretty much. Yeah, that's pretty much what we learned here. Cool. So let's see what's next. So it provides signed and unsigned integers in 8, 16, and 32 and 64-bit forms. Okay, I don't understand what this means for now. These integers follow a naming convention similar to C, in that an 8-bit unsigned integer is of type uint8. And okay, maybe I was wrong with the signing of it. Swift provides, okay, cool. No, but then it says these integers follow a naming convention similar to C, and that an 8-bit unsigned integer is of type uint8, and a 32-bit unsigned integer is of type int32. Okay, I guess I'm a bit lost here, but we'll get to it. Like all types in Swift, these integer types have capital names, have capitalized names. Okay, cool. Integer bounds. You can access the minimum and maximum values of integer type with its min and max properties. You can access the minimum and maximum values of each integer type with its min and max properties. Minimum value is equal to 8 and is of type unit 8. Maximum value is equal to 255 and is of type uint 8. Okay, so we see this types. The signed, this types. Okay, what do we mean here? Okay, let's try and see. Let, okay, which means a constant, min value int a minimum. So what will happen if I print min value? Says the minimum value is 0, which, what does it mean, 0? Okay, let's make the maximum value then. Then max value is equal to ui int 8 max, and then let's print max value. Okay, the maximum value is 255. Okay, what this reminds me of, I know that, for example, if we create a table in a database, we can assign the number of characters inside the value. But then can the number of characters be 255? Okay, cool. That's what I think I understand. I could be wrong though. But then 2555, that means 25555 characters. Is that what it means? Because we do know, I think we do know that, for example, if, or maybe I'm reasoning from a database point of view here, but let's say you create a table called people, right? And one of the fields that you have is name, which is of type string, which takes 255 characters. So now, the moment we have, let's say, a name with as many characters that exceed 255, it's gonna cut down. Those are some of the things that I see. So then can we set the number of characters that an integer can take? I don't know if we can do that. If this is the concept that is applying here, that is applicable here, then that means average value ui int 8. Now I want to see if I can set. I don't know what stride is from integer literally. Bit width. What is bit width? What is bit width? Obviously, is this? Okay, I don't really know bit width. I don't know if I can set bit width or what, but then so far, I don't know if it's an attribute or what, but let's try to print it. Expected and member named cannot print. Okay, average value. So let's just only display to this point here and see. Okay, we see it displayed 8. Bit width is 8 bits. Okay, it makes sense what bit width is. Wow, because obviously it takes us back to bits and bytes. And we know a bit. Let's check here. What is a bit? As we can see in 1, 2, 3, 4, 5, 6, 7, 8. So the bit width here is 8. Say total characters that 8-bit can take. 256 character. 1 byte character set can contain 256 characters. I guess for us it's 255, beginning from 0. So if I'm saying it correctly, because the maximum, as we came to see here, the maximum value is 265. Provided we're counting from 0, then it will make sense. But then obviously here we may be counting from 1. Hence it says 256. Okay, I don't really know correctly, but then that's what I think can be happening here. So I think this unit 8 max simply says our maximum value can have a total number of 255 values like this. Let's test it out. Let's be that guy. Let's just gonna test it out. A number with 255 values. Should I say characters? Can I find one? I don't know if I can, but let's see. I mean, why am I doing this? Why am I taking a lot of time just busy out here doing this? Okay, well, it seems like there's so many interesting things about it. But no, it cannot mean that. What if we can make, but no, that's not gonna work. Should I say example? The one thing that came to my mind is, what if I can make something like, what is this? A function that can generate 255 characters. But then that means I need to create a string that's gonna loop, and as it loops, it increments the string with the value 1. And then after it does that, it converts that string into a number. And after converting the string to a number, I can then store the number inside a value. But then how would I test, obviously, if that is working or not? Okay, it's gonna take me a lot of time, so I think it's best to move on. But I think that's what it means, though, and I'm open to corrections. I guess maybe the future will correct me. But I think this is what it means, that as we can see here, let the maximum value 8 max. So let's see with something, because obviously if what I'm saying here is true, then we can test with the minimum. Let's say min value is equal to, and see if this is gonna work, because obviously we know, ooh, okay, it's a constant. Let me make it a variable. Correct. So we are right with our thing. So as we can see, it can only take one value. Let's see. It can only take one value up until 9, because that's the minimum that it can take. As we can see here, the first one is 0. That means it can only take one value. But then the moment we cross into double digits, it overflows. Let's see if that is the case. Okay, it's not overflowing. Okay, it's still not overflowing. Cool, it's not overflowing. Okay, integer literal overflows when stored into UI int 8. Okay, let me check something. Probably this could be the maximum number that, but then would it make sense though? Let me see if I do 6. Okay. So I think what this means is that the maximum number that this can take is 255. And it's not the maximum number of characters, but rather it's the maximum number itself. Because obviously now it works fine. We can print 255, but in the moment that I cross to 6, 256, then it overflows according to this thing. The maximum number that this can take is 255, from 0 to 255. So then what if I do with max value? Well, either way, it's still not going to work because it's of uint 8. That's pretty much what we see here. Because what I did here, I think I assigned the initial value, because obviously this is a value. If I do this, if I say, for example, print uint 8.max, this is a value. This is a value. So I assigned this thing here a value of 255. That's just what I did. Well, that's just what I did. But then what will happen if I say var my number is equal to 0, and then I say my number, then obviously there's no rule behind this. It should be okay because I didn't specify it as this. But then that's quite interesting though, because now how come if, for example, how come if I do this and I say, well, this is a let me make this a variable first of all. Tells me about the overflow. And now my number should be fine. It shouldn't have a problem. But then if I do this 255, it doesn't have a problem. What is this assignment here? What does it mean? And I think that's where it gets interesting. So let's see something. Var, because if I say var my number is equal to 255, it doesn't recognize this as the maximum. So I can continue on adding more numbers into this until as I like. It shouldn't give me a problem. But in the moment var, okay, cool, the issue is here. It shouldn't give me a problem in the second statement here. Let's see if it's an overflow again. Overflows when stored into an int. Okay, so there's an overflow. But then again, what we do know is that there's a maximum number of characters that an integer can take, because obviously we don't know how it is set. I just do not know the maximum number of this kind of integer here. Let's see if it's gonna work or not. Okay, it's walking. Let's see. Okay, it's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 11. No, that's not a smart way to go about this. I wonder if there's a way of testing my number, the maximum value. Okay, let's check the bit width of this thing. I think it's an attribute. Okay, my number has a bit width of 64. So that means, let's do this then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. 20, 30, 40, 50, 60. It should complain. It should complain. 60, 61, 62, 63, 64. Okay, so it's, oh, well, that's a 0. That's a 0. Because it rounds all these things at 0. So then if I do this, then it should complain now. Okay, so what will happen if I remove this 0 here? Yeah, it wouldn't make sense because all those zeros, it makes sense. They will all get erased and get used as a single 0. That's pretty much what the compiler is gonna do with them. But then what does it mean? The bit width is 64. Does it mean we can take 64 characters or what? Interesting question that I do not have an answer to at this moment. But let me just continue here. Okay, cool. Okay, we'll get into that. And I think it'll make sense for us when we get into it. But for now, let's continue with what we're busy with. Cool. This integer follows a naming convention similar to C in that an 8-bit unsigned integer is of type uint8 and a 32-bit signed integer is of type int32. Like all types in Swift, these integer types have capitalized names. Okay. Integer bounds. What is an integer bounds? You can accept the minimum and maximum values of an integer. Okay, cool. That's where we were. So all along I was just mixing this with something wrong. So these are called integer bounds. Okay, so we're looking into integer bounds and we're trying to think what integer bounds are. You can access the minimum and maximum number. You can access the minimum and maximum values of each integer type with its min and max properties. Okay. Min value is equal to 0 and is of type uint8. Let max value is equal to 255 and is of type. Okay. But then we came to learn something here because we talked about this, but then yet we were able to do this. Let me just do an undo here. I was able to say min value is equal to 255 and we didn't have a problem. But then it says you can access the minimum and maximum value of each integer. Okay, I see what it means now. Minimum value is equal to 0. So that means the minimum value of this integer cannot be -1. And it shows. that it cannot be -1 because the minimum value is equal to 0 and the maximum value is equal to 255. So fine, we can do this 255. That's fine. We can even do any number. We can store any number that is greater than 0, that is greater or equal to 0. This means we can store any number that is greater or equal to 0, but not greater than 255. I think that's pretty much what it means, because obviously we know what the maximum value is. For example, if I come to minimum value and I say the minimum value of 256, then it should complain. Oh, I didn't say anything here. Cool. It should complain because it's more than the maximum value of UI of uint 8. Okay, cool. That's what we call integer bounds. Interesting term. I wonder why it's called integer bounds. The values in these properties are of the appropriate sized number of the appropriate sized number type, and it can therefore be used in expressions alongside other values of the same type. Okay. Cool. We know what integer bounds are. That's pretty much, I'll say, I'll just put it that way, setting boundaries for integers. We have an int. So what in most cases you don't need to pick a specific size of integer to use in your code. Okay, that makes sense. I mean, yeah, that makes sense. Swift provides an additional integer type int, which has the same size as the current platform's native word size. On a 32-bit platform, int is the same as size 32. On a 64-bit platform, int is the same size as 64. Okay, let's see what's going on here. Unless you need to work with a specific size of integer, always use int for integer values in your code. This aids code consistency and interoperability. Even on the 32-bit platform, it can store any value between negative, what is this number here? I think it's 2 billion. I don't know. And it's large enough for many integer ranges. Okay. Uint. I don't know what the word uint stands for. Could be quite interesting though. What does the word uint stand for? On a 32-bit platform, uint is the same size as uint32. On a 64-bit platform, uint is the same size as 64. Note: use uint only when you specifically need an unassigned integer type with the same size as the platform's native word size. If this isn't the case, int is preferred even when the values to be stored are known to be non-negotiable. A consistent use of int for integer values aids code interoperability, avoids the need to convert between different number types, and matches integer type inference as described. Okay, I don't understand what I just read there. I think I'll just end it here for integers because I'm sure the video is getting longer now. How many minutes has it been? Let me check. Well, 30 minutes, that's very long. Yeah, I'm just gonna end it here, guys. Cheers.